Hi class, I am at a math training today. Uh, you have a couple things that you need to do first off in the beginning of class. Please turn in your packet from Thursday. Please put that into the basket. Then get on Dreambox for the next 10 minutes. I will have a video lesson in those next 10 minutes, and then I will get you time to work on your homework. So please pause the video, allow students to turn in their packet to the basket, and get onto Dreambox on their Chromebooks for the next 10 minutes. Please restart the video in approximately 10 minutes. Yesterday we started with our essential question of how can you display data in ways that help you make decisions. We talked about a lot of different types of displays, and you were able to hopefully use some of those in your packet yesterday to come up with a display of the data that we were listing. This is one of our examples for today, analyze and display the data in a way that best describes it. Explain your choice. So we have student quiz scores. You can see we have 6 quizzes and there are their scores. So there's a lot of different things that we can do. One of the things that we could do is make a bar graph. We would have quizzes at the bottom and then the scores going up. We could make a line graph because a line graph would show us data over time. Each of those quizzes would be over the time. We could do a stem and leaf plot. We would have the 7s with a 7 behind it, the 8s with a 2, a 4, and an 8 behind it, a 9 with a 1, and then a 10 with a 0 also. Or we could also do a box and whiskers. We talked very briefly the other day about box and whiskers, but the bottom would be 77, the top would be 100, and then we would have a couple other things in the middle, the median between these two right here. So this is one of the ways. There's a lot of different choices, and as some of you found out on Thursday, some of them are a little bit easier and a little bit more efficient to use. Here are a couple more examples. The number of students in marching band each year. There's a couple different things that you could do since it's change over time because it's talking about year. Anytime we have change over time, a line graph is probably our best data display. We're comparing people's shoe sizes and their heights. We've done a couple of these. We have 2 different sets of data, shoe sizes and heights. Therefore, we would probably use a scatter plot. When we talk about the population of the United States divided into age groups, we would probably use a histogram because we would break them into even groups, maybe 0 to 10, 11 or 10 to 20, and so on, so that we could come up with those intervals of the same size. The percents of students in your school who play basketball, soccer, and lacrosse, and football, we could use a bar graph. Possibly we might use a circle graph as well, but bar graph would probably be our best answer for that one. Our next example is you record the number of hits for your school's new website for 5 months. Tell whether the data display is appropriate for representing how the number of hits changed during 5 months. As you can see, in August we had about 250, 320 in September. October went up, and up. So I believe this first example, the bar graph does show the number of hits for each month, so it is an appropriate display. In our second example, we have this one, which shows a histogram because we're talking about this, but it doesn't really tell me which months they're talking about. It told me that we had 2 between 0 and 399. We had 2 that were between 400 and 799. And then we had 1 that was between 800 and 1199. It doesn't show me the different months. So the second example, the histogram, does not show the number of hits for each month or how the number of hits changes over time. So it is not appropriate for that display. In our last one, this is change over time. So you can see in August to September, it went up and it kept going up in those. So the line graph does show the number of hits over time, so it is an appropriate display. Yesterday I mentioned to some groups that their graph was a little misleading. We talked a little bit about it with the circle graph not having enough of the circle covered for something that was less than half. So these are both box office revenue for probably movie theaters. They have total revenue in billions of dollars on the side, and we have the years. There are two different examples of this, but this one is the actual best one for this. This one's a little misleading because you can see this is a broken graph, and this one really looks like it's going up a lot when actually we're really not going up a whole lot. We're going up $1 billion or so, and it looks a little bit misleading that it looks like it goes up a lot. So you can see the vertical axis on the line has a break in it right here, and it begins at 8. This graph makes it appear that it goes up a lot faster than it actually does. This is the one that is the best fit. This one would be our misleading example. In our next example, a volunteer concludes that the number of cans of food right here is the same as the number of food boxes that are donated as well. Is this conclusion accurate? Well, as you can see, each of the figures below, the cans, the boxes, or the juice bottles, they each equal 20. So this first one is 20, 40, 60, 80, 100, 20, 40, 60, 80, 220. So there are 220 canned foods. In the boxes, we've got 20, 40, 60, 80, 100, and 20. So you can see there's a big difference in there. The reason that this is misleading is because they look like they are about the same area, even though the cans are worth just as much as each box, and you can see the difference. So each icon is the same number of items, but the box is larger, so it looks like they are about the same. This is why this is misleading or not accurate. In our last couple problems, why is the data misleading in the concert ticket prices? Again, you can see the broken graph right here. It looks like these are almost double. This one's actually double the size of this first one, and it's not. So if it was double 40, it should be at 80, and you can see it's about 53. So this, because of that broken graph, it is a little bit misleading. In our second example, this first one is a little bit skinnier. It gets a little bigger, gets a little bigger, gets a little bigger. So the profits in year 5 look like they are a little bit bigger than they actually are. So you can see the tickets vary in width, and the break line in the vertical axis makes the difference in ticket prices appear to be large. The bars become wider as the years progress, making the increase in profit look greater. So the two things that you will be working on today are coming up with an appropriate data display. You can use the chart in the book, or I will try to get it put up here very shortly as well. You will also be determining whether or not a display is reliable or is misleading. If it's not, you can come up with a reason for that. So what I have for you to do the rest of class period is your homework is from the textbook. It's page 397 and 398. It's problems 4 through 14. We will turn this in on Monday, and you have the rest of class period to work on this problem set. Thanks and have a great day. Here are the first set of 5 problems, problems 4 through 8. You can pause this if students need to see the textbook. Here are problems 9 and 10 for students to use. You can pause this if they need to see that. And lastly, here are problems 11 through 14 for students if they need to look at a problem and not use the book. Have a great day.